Hi class. For this week's video we're going to talk about methods. When we talk about methods, as I spoke to in class, we are talking about code reuse. Taking some of your code and putting it into a reusable container that you can call and use in other places of your application. I want to make a quick note, if you're having trouble hearing me today, it's because I'm sick. So sorry about the voice. And this may be a bit shorter than usual because I don't know how long I'll be able to talk. So on your screen, you see a blank application. And let's say we wanted to write something to the screen. Console.WriteLine, hello. And we can run this application. And we see that we've written hello to the screen. Let me just increase my font size a bit here. So we see we've written hello to the screen. This can also be done through a method. We can take a bit of code and encapsulate it in what's called a method and be able to call that method to perform the same function. So let's create a new method. Say hello. And we're going to take this bit of code and we're going to place it in the method. Before I go any further, let's talk about what it takes to build a method. A method, as I said, is an encapsulation of code. It allows you to reuse a piece of code over and over and call it simply by name. We haven't gone over classes yet, so the word static really won't mean anything to you. But what static represents is whether or not a method is part of a class instance or if it's part of the class definition. In this case, it's part of the definition of the class program. So it's in the common memory structure of the definition of the class program. And again, it really won't mean anything, but it will be accessible by any other method declared static or by any of the instances of the class declared static. For now, just write static. We'll talk about this in 2 weeks. Next is void. This is your type. Just like a variable, a method can return a value or have a value. In this case, this method does not return any value. If a method does not return anything, it simply has the type void. Finally, the method name, here we're calling it say hello. It should be a name that describes what your method does. We'll talk about this in a few minutes, but if you notice the main method at the top here, it has parameters defined within 2 parentheses. We'll talk about parameters in a minute, but for now just put an open and close parentheses since this method has no parameters. Parameters allow you to input arguments or send data to a method. Once the method definition is created, the next part is the code block. Open and close squiggly brackets you can use, just like building an if statement or a switch statement. And inside is all the code to be executed when this method is called. So how do we call, or sometimes we'll use the word invoke, a method? we notice the method name is say hello with an open parentheses and close parenthesis. So let's go ahead and copy that and paste it where the original code was. So here we see say hello. We've called the method by name. We've opened a parenthesis, closed a parenthesis, and put a semicolon. That's how you invoke or call a method. If we run this application again, you'll see we do the same exact thing that we did before. We say hello. So how does this work? So we called the main method, and then we called or invoked say hello. So what does that do? That jumps down to the method that we defined, say hello. It then goes through this method and runs the code defined within the method itself. So here, console.writeLine hello. When we've reached all the code at the end of the method, which here we only have one line, it jumps back to the next position. So we've gone from line 13 to line 14, and then console.readLine is called to keep the window open. That's how a method works. Again, we've encapsulated code, we can call it, and then go back and continue code execution. Methods can take arguments, and you define what arguments it can take by creating parameters. So with the say hello method, all we did was say hello. We didn't take any input. We just wrote a string hello to the screen. So instead, let's call this method say anything, and we want to be able to write an arbitrary string to the screen. We do this by defining a parameter. String thing to say, and we'll replace hello with the parameter thing to say. So what we've done here is we've changed the name of our method because we're doing something different now. We're saying anything, and we're accepting a string that says thing to say. So we're going to change the call here, and we're going to pass a string to the method. Look at this string. So let's break down what we've done here. We talked about the method definition before. You have your instance item. You have the type of the method. You have the name of the method. And within the parentheses, you have the method's parameters. I've shown one parameter here, but you can have multiple parameters. Our first parameter we've defined is a string type, and the variable is thing to say. What this does, it creates a variable representation of what's passed into the method. If we jump back up to line 13, we have passed a string into the method. Look at this string. That value is assigned to thing to say. We can then access this variable throughout the method. So here on line 20, our console.writeLine method, we can access the variable thing to say and the value that was passed to it. Look at this string and write that to the console. So just as we did before, let's run this application. And we see that look at this string is written to the screen. That is the argument that was passed to the parameter thing to say, and then the variable thing to say was then passed to console.writeLine and written to the screen. Methods can also return a value. So before we said a static bool say anything, or sorry, a static void say anything, because we just wrote something to the screen and didn't ask for anything back. A lot of times you'll see a method that will return a result. So maybe we want to know, did we successfully write something to the screen. So let's walk through what I just did. First, I changed the type of the method from void to bool. We're going to return true or false based on whether or not we were able to write something to the screen. In this case, it's always going to be true because we simply wrote something to the screen. We continued with writing our line to the screen, and then we use something called a return statement. And a return statement allows you to pass a value back to the code calling the method. Here we wrote return true. We're returning true. Back in our main method, we defined a variable called result, and now result equals the return of this method. In this case, it will be true. We can then write using string interpolation the result back to the screen. So let's run this application. And we see not only did we write the string to the screen, but we were also able to get a return value back from the method. Another example of what I did in class the other day. Let's delete this method. I created a method, static string day int day to string int day of week, and basically we took an input value 1 or 0 through 6 and converted that to a string representation of a day of the week. So we switched. We have an input parameter of int day of week, switch on day of week, and then we ran through each day. Case 0, return Sunday. Case 1. So what I've done here is I have created a method called int_data_string. I've accepted a day of the week as an integer from 0 to 6, and I've converted that to the equivalent day of the week as a string, Sunday through Saturday. So here, if I created a for loop, int day equals 0, day is less than 7, day plus plus. I can then call, I'll do a console.writeLine int day to string day, and display each day to the screen. If I run this, you see each day of the week was then written to the screen. Again, what we did was we took a parameter, we created a parameter, int day of week. We accept any arguments of the day of the week into this parameter, and we're returning a string as defined on line 19. We can also have optional arguments. So let's say we want to know whether or not the day of the week should be in all caps. Bool all caps equals false. And based on whether or not all caps is false, we return a different value. So if all caps return Sunday, else return Sunday, and then we will do this for each one. So what I've done here is I've created a new parameter called all caps, which is a Boolean, but I've assigned it a default value of false, meaning I don't necessarily have to pass an argument into this parameter. If I don't, it will simply be false by default. If I run this application again, you'll see I show each day of the week in camel case, because by default all caps was false. However, I can choose to pass something into this parameter, so I can pass the argument of true, run it again, and you'll see in this case each of these was capitalized because I chose to override the optional parameter of all caps. Please note that optional parameters need to be placed after all non-optional parameters. A non-optional parameter does not have a default value. An optional parameter does have a default value. If I went ahead and tried to do this by placing the default value first, I would get an error, and you'll see here optional parameters must appear after all required parameters. So again, please remember, put them to the right of all non-optional parameters. I want to take a minute to talk about method overloading as well. So method overloading, well, let me back up. Methods perform a task. So we talked about int.parse as an example. Int.parse, the task is to parse a variable into an integer. However, that variable may be of one of many types. It could be a string, it could be a double, it could be a character value. But all of those represent different methods that perform the same function. So, actually, before I do this, I could int data string, we're accepting an integer. Let me get rid of the optional parameter here, just for the sake of clarity. So here, in int data string, we're accepting an integer. So let's take this out. Let's just pass 1 as the day. We're going to get Monday. So we run this, and we get Monday because we're on line 13. We're passing in 1 as the argument. But what if I passed in 1 as a string? Well, I'm going to get yelled at, and it's going to say cannot convert from string to int. So what if I wanted to, again, create another method, but allow, still convert an integer data string, but accept a string instead of an integer to accomplish the same task? Int data string day of week. So what I've done here is I've created a new method. We're going to return something real quick just so I don't get yelled at by the compiler. I've created a new method, but instead of an integer day of week, I am accepting a string day of week. So here, if we look at our definition of int day to string, we see we have 2 different methods that accomplish the same thing. We can either type in an integer, like 1, or we can type in a string, like this, in quotation marks, and still accomplish the same task. Well, how would I do this in the method itself? Well, I could simply call it this way. Return int data string int.parse day of week. So essentially what I did was I passed it off to the original method we wrote by parsing this string as an integer and returning a value. So now we'll change this back to an integer. Int data string, run this, we get Monday by passing in 1. Int data string with 1 as a string, I pass this in, and we get Monday as well. So that's method overloading. You could create 2 methods with the same name, but different parameters. Now let's talk about recursion for a minute. Recursion allows you well, before we talk about recursion, let's talk about by value versus by reference. So if I had a variable int myInt equals 4, and we wanted to create a method static void add 1 to myInt. And we first will console.writeLine myInt equals myInt. We will do this again, and we're going to call the method add 1 to myInt and put it in between these 2. So ask yourself, what do you think will happen here? So we've defined a variable myInt and initialized it to 4. We're writing myInt to the screen, and then we just wrote a method add 1 to myInt, which increases the value of the integer by 1. and then we're writing the value of my int to the screen, and that's it. So what do you think happens here? Logically, you would think, well, we would write 4, we would add 1, and then write 5 to the screen, right? Well, that's not necessarily the case. If we run this application, we see we get 4 and 4. So why is this? When you pass a variable or a value into a method as an argument, you're passing it by what's called by value. Instead of sending the memory reference to the method and having it write the original variable, the interpreter is creating a copy of the variable and sending that to the method. So even if you had a variable myInt equal to 4 in the main method, as you do on line 13, when we pass that off on line 17 to the method add 1 to myInt, it's creating a copy of myInt in memory and adding 1 to that copy. If instead you want to edit the original variable, you want to pass it by reference. So instead of passing the value, you're passing the memory reference to that variable. There's a very easy syntax in C# to do this. It's called the ref syntax. So here we have the ref keyword to our method definition, and then we add ref when we make the call. So now, instead of passing the value, we're passing the reference. So when we add 1 to the parameter input, that is actually adding 1 to the reference to myInt. So now, if we run this application, we see 4 and 5. There is another reference notation in C# called out. It's, for your purposes, unnecessary at this time. But you should be aware that when you edit a variable in a method, you're only editing the copy. You're not editing the original. And if you want to edit the original, you need to use the ref keyword. So the last topic we'll cover is method recursion. So method recursion is pretty easy. Basically, it means a method calling itself. You'll see this a lot of times when you talk about Fibonacci sequences, when you talk about merge sort, quick sort, different sorting and searching algorithms. You'll hear it talked about when you do file tree traversals and folder tree traversals. If you want to access a file within 5 layers on a hard disk, you're going to want to run a recursive method in order to traverse all the files and folders. You can think of recursive methods as a tree structure. A loop is linear, 1, 2, 3, 4, 5. Running a recursive method creates a tree with branches and nodes. I really won't get into much to recursive methods, but again, you should know that a recursive method calls itself. So a recursive method here, we'll call this my recursive method. And let's create an int called count. And we're going to call in here my recursive method and pass count. And each time we're going to do 2 things. We're going to check if count is less than 10. That's the only time we're going to do this. Add 1 to count and call the method again and write it to the screen. do here is we will call my recursive method with a value of 0. So let's look what we did here. We are calling a recursive method once that calls itself. And we're initializing it with a value of 0. We're passing 0 as the argument to the parameter int count. So we jump to this method. We are writing to the screen, running my recursive method with count equals count. As long as the count is less than 10, we're going to increase the count by run and rerun the method, my recursive method with the increased count. So let's run this application. Oh, sorry, I forgot console.readline here. And we see that we wrote this to the screen 11 times here. So what we've done is we've called this method within itself over and over and over again. Now you may be asking, well, why did we hit the 10th one when count is less than 10 here? Because count here would be 9. 9 is still less than 10, and we hit 10 by adding 1 to count. But again, what we've done is we've essentially created a loop. You could have done this with a for loop. You could have done this with a while loop. We're not going to get into recursive methods that build out trees. But what we've done here is essentially created a loop by just creating a method that calls itself over and over until a condition is met. Here our condition was if count is less than 10. So again, recursive methods are useful, but more useful once you start getting into more complicated algorithms, searching and sorting and tree structures. But it's good to know that a recursive method is essentially, all it is a method that calls itself. So these are the topics for this week on methods. If you have any questions, please shoot me an email. But first, you should really be referring to the message boards on Blackboard and posting into course questions for other students to answer. Again, my apologies this week that this is one single video. Also, that I am having trouble speaking. So I look forward to seeing you guys in class next week. Thanks.